All right, today we're going to talk about how to solve these exponential functions when there's not a common base, okay? What they mean by common base is they're talking about, right, the base that the exponent is attached to, okay? So when you're looking at this problem, and actually any of the problems, what's going to end up happening is that this guy right here and this will have a relationship. What does that mean? That means that this squared equals this, okay? Moving a little bit ahead, just ahead of ourselves for a second, if you look, right, this and this, 2 to the third equals 8. All right, here, this guy raised to the 5th power will be 32. So what am I trying to say? What I'm trying to say is that whenever you're doing these problems, especially in the beginning of Algebra 2, not beginning, I'm sorry, beginning of these kind of lessons with Algebra 2, they try to keep it simple. Okay, when you get more into pre-calc, into calc and all that stuff, it's going to get a little more tricky. But for you guys, for right now, there's going to be some kind of relationship with these both. Okay, I could have kept going, but I don't want to get too far ahead of myself. So let's just, let me erase all this stuff. All right, so how does that help us? How does knowing that or trying to, notice that before the problem, how does that help you out? Well, what we're going to do is if I rewrite this side of the problem, if I rewrite this 36 as 6 to the second, well now, if you see, right, we have the same base, which means we can do what we did, what you guys did yesterday from the video, is if the bases are the same, well then we know that the exponents have to be equal to each other. So I know that 2x minus 10 equals 2, and now I just solve this like I would a problem back in algebra. Okay, now we always want to check our answer. So let's just put 6 in for x. I'll get 2 times 6 minus 10 equals 36. That gives me 6, 12 minus 10 equals 36. Okay, it's going to be right, just to finish the problem, right? So we're good. This is my answer. Okay, for this one, again, what's the relationship between the bases? So 2 and 8 have a relationship. 2 right? 8 can be rewritten as a base of 2, all right? The reason, and one of the common mistakes that I see a lot of students do is like they'll look at the 2 and the 8 and they'll say, oh, like 2 to the third, and they'll try to multiply all this stuff. But then we've just changed the whole problem. We've raised something to the 3rd power, and we haven't done anything over here to balance it out. So that is not something you should be doing. The reason why we're allowed to do this is because I haven't changed anything from here to here, right? 8 is just 2 to the third. I have not changed any value in the problem just yet. But what I have done is made the same base on the right and the left side of the equation, which means p minus 7 has to equal 3. And I get p equals 10. Let's just check our work. If I put 10 in for p, I get 2 to the third equals 8. That is correct, so I am good. All right, we're going to skip the fraction. We're going to skip number 7. We're going to come back to number 7 tomorrow. We'll just make the fraction ones just their own thing. So again, what I'm trying to do is rewrite one of these bases, right? Not do anything like cube this 2 or raise this 2 to the 5th power or anything like that. I'm just trying to rewrite one of them. Sorry. I'm just trying to rewrite one of them. So on the left side, let's just keep it. But I can rewrite this 32 like with base 2, right? 2 to the 5th power. Now that I have the same base, right, I can just set the exponents equal to each other. So one of the things, if you've noticed so far, is that definitely want a graphing calculator or some kind of calculator, because a lot of these are, cubes to the 4th, to the 5th, to the 6th. So knowing that is really useful for me, and that's why I'm doing these so quickly. But for you guys, okay, definitely having a graphing calculator or something to check your work as you're going through, because hopefully by now you're looking at this and saying, okay, 2 and 32, 32's got to be 2 raised to some power. And it's just nice to have a calculator because then you can check it really quickly. Okay, and then let's see, 7 times 2 is 14. So I get 32 equals 2 to the 5th. Yes, it does. That's my answer. All right. So again, 27, 3. Is there a way I can rewrite one of them so that it's the same base as the other, right? The 27 I can rewrite as 3 to the 3rd. Okay, now they have the same bases. So now I have 2x plus 6, and over here I have 2x. Now that I have the same bases, that means the exponents have to equal each other, so I get 3, 2x plus 6 equals 2x. And again, now you're just solving it like a algebra 1 problem. So I get 6x plus 18 equals 2x. Let's subtract 6x on both sides. I get 9 over 2, right? And that's negative. Okay. All right, so to check this, and this is kind of why I did it, I just kind of skipped ahead because I kind of knew as we got our answer, checking it's a little weird. So if I put negative 9 over 2, or for you guys, I'm sure some of you probably did negative 4.5. If you put that back in here, okay, it does actually work. Over here is my work, actually. You just got to be really comfortable with multiplying with the fractions. So if I multiply 2 by negative 9 over 2, you're just left with the numerator, right? So if they cancel out, you're just left with 3 to the negative 9. On the left side of the equation, if I put in negative 9 over 2 right here, again, if I'm multiplying a fraction by a whole number, and the denominator is that whole number that I'm multiplying by, I'm left with just the numerator. So I just have this negative 9 there. Okay, and that's all something that you should know by now. But when you multiply negative 9 over 2 times 2, right, it gives you that numerator. So anyway, so now you have 27 to the negative 3 equals 3 to the negative 9. When you have a negative exponent, you can make it positive by putting the base on the bottom of a fraction, right? If you remember that, hopefully, from class. And again, to make this a positive 9, I just put it on the bottom of a fraction. Is it easy to see this right here, that these two are equal? No, so I try to make it a little more clear because I don't have a calculator with me, and even if I did, I wouldn't be able to show it to you. So 27 to the 3rd, and then 3 to the 9th, how are they equal to each other? Well, 3 to the 9th is just like 3 to the 3rd to the 3rd. If you don't remember that, you can check your exponent rules. But 3 to the 3rd is 27. So 27 to the 3rd power equaling 27 to the 3rd power. Yes, that is correct. So our answer does work out. All right, next. These get a little tricky. But just like on the first page, this and this are going to be written in the same base. But instead of... like on the first page, we picked like the smaller one. We figured out like what exponent up here would give us 125. Well, even if we picked a low number like 2, 25 to the 2nd power is going to be like, 625 or something like that. So that's definitely not it. So what you have to realize, hopefully, is at this point in Algebra 2, you should be able to at least recognize perfect squares, perfect cubes, something like that. That's going to help you out a lot. So I'm hoping some of you are like, oh, okay, 25 is just 5 to the 2nd. Oh, can I rewrite this as 5 raised to something? 5 raised to what gives me 125? That would be a 3, right? And then we still have this y here. So all I've done from here to here is I've just rewritten 125 as 5 to the 3rd, and I've rewritten 25 as 5 squared. That's all I've done. Okay, I have not changed the value of anything on here yet. Now that they are the same bases, I can get rid of them. Okay, and I get my answer of 2 over 3. Check my work, right? Hopefully you have a calculator. Right? One of the things we learned right before everything happened was that this exponent can be rewritten as the cube root of 125 squared, right? This bottom part is my index, and then this top part is my exponent, right? The cube root of 125 is 5. 5 squared, does that equal 25? Yes, it does. This is my answer checked. All right, coming from a teacher, this one and this one and stuff like that, people always mess up, and the reason is because they see the 4, they see the 8, they're like, oh, multiply by 2. We're not doing multiplication, okay? What we're doing is we're raising something to a power. So 4 raised to 2 would give me 16, which is not 8, okay? So be careful with these, all right? And let's go back to number 12. Same thing here. People see 8 and 16, they say, oh, like 8 to the second is going to give me 16, because they get mixed up with multiplication and raising something to a power. So just like on 11, we're saying to ourselves, okay, we have 16, we have 8. We need to make them have the same base, right? Is there anything that we see with 16 and with 8? I'm hoping. One, you know that 16 is a perfect square, right? 4 squared. But 8 is not a perfect square. It is a perfect cube though, right? And then you say to yourself, oh wait, it still is not the same base. Can I mess with it still? Yeah, you could. But also, let's just go back for a second. Let's keep this 2 to the third, right? All I've done is rewritten 8 as 2 to the third. Can I rewrite 16 with base 2? Yes, you can. And again, this is why you have your graphing calculator. But 2 raised to the 4th power would give you 16. So all I've done on the problem so far is just rewritten 16 as 2 to the 4th and rewritten 8 as 2 to the 3rd. Okay, now I'm just filling in what was already there, right? So you don't want to change anything just yet. Now that you see, right, we made them the same base. Now I have 4 times 3x equaling 3x plus 2. Again, if we have the same bases, I know that my exponents are going to be equal to each other. Now you just solve it, just like an algebra problem. Okay, you always want to reduce your fractions. And let's just make sure that this checks out. So 16 raised to the 3 times 2 thirds equals x 2 thirds plus 2. That would give me 16. Why did I put an x there? That's an 8. 16 raised to the second equals 8 2 thirds plus 2. If we add these fractions, 2 thirds plus 2 is just like 4 over 2. Sorry, not 4 over 2, 6 over 3, because I want the same denominator, which gives me 8 over 3. So that gives me 16 raised to the second is the same as doing 8 raised to the 8 over 3. Does that equal each other? It does, but let's just kind of keep going here. If I rewrite this as 4 to the second equals the cube root of 8, which is 2 to the 8th, and then I do this again, that would give me 2 to the 2 to the 2 to the 2 equaling 2 to the 8th, which is correct, all right? If I lost you there, all I was doing was using my exponent laws. So if I see a 4, I can rewrite the 4 as 2 to this, let me change the color. I can rewrite the 4 as 2 to the second, and then I just have this 2 times 2 still here, all right?